Comparing simple and compound interest graphically. What we have here in example 1 is $10 being increased via some interest rate, in this case 3% per year, in a number of different scenarios. The first scenario here, our $10 increases at 3% per year simply. That is, we have simple interest. And then in the remaining examples, we have different versions of compound interest here. In the first one, we have semi-annual compounding. Then we have, in the first one we have annual compounding. In the second one, we have semi-annual compounding, quarterly compounding, monthly compounding, and then we get up to daily compounding. And what we're going to do is graph all of these, and we'll actually graph them simultaneously, and we'll see if we can't see the differences between them. So let's go into our y equals menu and enter all of these equations first. So we're going to enter 7 different equations. We're going to use 7 of the first 7 y's that we see here. So y1, I'm going to put in the formula for simple interest. So I'm going to type that in as we see it, 10. And then I'll open a left parenthesis. And the calculator understands the assumed multiplication there. We're going to have 1 plus 0.03, and then we'll use x. Because that's the variable the calculator likes to work with. And then we'll close the parenthesis. So in the calculator we're going to use x, where in the examples we see t. So x is going to be our time value. Y's are going to be our accumulated amounts, or future values, if you will. All right, let's continue. The second one's going to be 10 times, we open the parenthesis, 1 plus 0.03 divided by 1. And then we're going to close the parenthesis. We don't really need the divided by 1 there, obviously. And we'll say to the x power, 1 times x if you use the formula from the textbook. All right, enter. For y3, we're going to put 10, open a parenthesis, 1 plus 0.03 divided by 2 now for semi-annual compounding. Close the parenthesis. And we're going to raise that to the 2x power. Since we have an operation multiplication going on our exponent, we're going to make sure that we put it in parentheses to make sure the calculator does order of operations the way we want it to. Enter. All right, the fourth one has quarterly compounding, so it's going to be 10, open a parenthesis, 1 plus 0.03 divided by 4, close the parenthesis around that expression, and we're going to raise to a power. And since we have an operation again, 4 times x, we'll put it in parentheses. So we'll have a left parenthesis, 4x, and then a right parenthesis. Enter. 2 more to go here. I think I said we were graphing 7. We're only graphing 6. 10 times 1 plus 0.03 divided by 12. Close parenthesis, to the open parenthesis, 12x, and close parenthesis. And 1 more to go for daily compounding. We will have 10, open parenthesis, 1 plus 0.03 divided by 365. Close the parenthesis, raise to a power, open a parenthesis, and we have 365 times x, or just 365x. Close the parenthesis and enter. All right. Now let's see what happens with these things over, maybe a period of 10 years to start with. So let's go into our window here, and we'll let x-min be 0. All of these things start with a value of $10, so we should all see them start from exactly the same point. Enter. And X max is already 10, so that'll get us out to 10 years. Um, we know our value is not going to go back below the $10 it starts at, so we can easily start at Y min of 0. We know we're not going to have any negative values. And at 3%, I don't know exactly how much this is going to grow, so let's give it a little room here. Let's say that maybe it doubles in 10 years at 3%. There is a rule of thumb that says money invested at 7% will double in 10 years, so we don't expect money at 3% to do so. So setting a Y max of 20 should really give us more than enough room here. All right, now that we have our window set, let's graph and see what we get. Now remember, these things graph in order. So the first graph we see is the simple interest graph. And once that graph is up, the second graph we will see is for annual compounding. And it's probably going to look a lot like the simple interest graph at first. We'll see if we see much of a difference here over 10 years. We see some action going on here. Not a lot of difference in these lines so far, at least not out at 10 years. We're just going to let the calculator go. Since they're so close together, I'm not sure exactly which one is being graphed at the moment, but we are starting to see a little bit of separation up here. And remember, we're looking at a small amount of money here. So we're not going to see a large absolute difference, but what we're interested in is kind of the fact that there is a difference, and the fact that the difference grows as you work your way down the list here. And it also grows the further out to the right, the larger your t-values are. Compound interest doesn't always look like that great of a deal over short periods of time, especially for low interest rates. But it's the long-term cumulative effects that really start to get to be a big deal. And that's true for exponential functions in general. If you think about it, if something doubles in 10 years, then your $10 becomes $20. But over the next 10 years, your $20 becomes $40. And over the next 10 years after that, your $40 becomes $80. So in the first 10 years, you get a $10 increase. In the second 10 years, you get a $20 increase. In the third 10 years, you get a $40 increase. And if you let things go for another 10 years, then you'd get an $80 increase the next time. So yeah, your money really starts to grow very quickly compared to that original $10 investment once you get out far enough in time. All right, my calculator is slowly working its way through all of these graphs. And something I'm going to note here is that we know we don't go below 10. We've already said that, and it doesn't look like I'm getting anything above maybe 15 or so out here. So to accentuate the differences in these graphs, maybe what we should do is go into the y equals menu and set y min to 10 and y max to 15, and then graph a second time. And I think something else I may do here, since my computer calculator is running so slowly, is not graph all 6 at the same time, but I'll turn some of them off and only look at maybe 2 or 3 at one time, and we can compare things that way. So hopefully it will finish graphing here shortly. And then we can move on. Something else that you can do as well, in addition to looking at the graphs of these things, is you can go into table mode and take a look at the different graphs. And you can look at all 6 of them. You're going to have to cursor to the left and to the right to take a look at things and compare everything. But you can look for small values of t, how there isn't a lot of difference, and as t gets larger, there is a large amount of difference in actual numerical value. And you can see that a little bit more easily in the table. All right, the first thing I'm going to do is go into the y equals menu here now that I've finally finished the graphing. And I'm going to turn off the middle graphs. I'm just going to leave the first graph, the simple interest graph, y1 turned on, and I'm going to leave the last graph with the daily compounding turned on. All right, remember to turn off a graph, you cursor once to the left initially to highlight the equal sign, and you press the enter key while you're on the equal sign to turn off the highlighting. And as you can see here, the only 2 equations I have left highlighted are y6 and y1. And I'm also going to go into the window, and I'm going to change, as I said before, Y min to 10 and Y max to just 15. I'm going to narrow that window a little bit to try to see the differences a little bit more powerfully. All right, so we'll press graph now. And again, the first one graphing here now is the simple interest. The very first formula we have, so it's just 3%. This is linear, by the way. This is a straight line equation. If you multiply through and rearrange, you can put this into slope-intercept form and determine what the slope and the y-intercept are. The rest of them are all exponential, and they're all exponential growth models, if you remember that from we talked about different exponential models. So we expect these things to have a little bit of a curve to them. And as we can see here as the second graphs, and again this is compound interest with daily compounding, we're getting into years 4, 5, 6, and beyond, and we're definitely starting to see some increasing here as a result of the compounding that we're getting. And as soon as this finishes, we'll press the trace key, and we'll look at how much difference there is at different points. All right, so if I press trace, right now I'm at x equal to 5, and if you look at the very top left of the screen, I'm on the simple interest formula y1. If you press either the up or down cursor keys, you'll move to the other graph, which is the compound interest with daily compounding, and you'll see the value there for x equal to 5 is 11.62 if you round to the nearest cent. That would be $11.62. So there's a difference here of about 12 cents on $10 over 5 years, which doesn't sound like a lot, but if you invested $100 or $1,000 or $10,000, that difference obviously grows with each one of those things and becomes a bigger deal. All right, let's try a different value. Let's try something like 10. All right, so we'll go over to the right side of the screen here. At 10, with compound interest, since that's the curve I'm currently on, I would have $13.50. I would have just $13 if I'd gone the simple interest route. So here I got an extra 50 cents over time. Now, again, I'm working with small numbers here, and I'm just simply trying to show you that there is a difference. I encourage you to play with all of these graphs and change the p-values, change the interest rates. You can and play with the graphs a little bit, maybe even look at things in the table. But it's exercises like these where you kind of take something that's similar but a little bit different and compare those differences that really start to, I think, help you understand a concept like compound interest, the difference between simple and compound interest, and the effects that playing with the multitude of variables we have in this situation can have on the different situations. Obviously, these differences that we're talking about will grow as you increase the interest rate, as you increase the amount invested, and we can see here on the graph here that they also increase just as t increases as we leave our money invested for a longer period of time. So go ahead and play with this. I just wanted to get you started in thinking a little bit about some of these differences, and that's that.